Okay, now that we have been solving number type problems with our factoring skills that we've been working on, we are going to return to geometry type problems. Just like we've seen before, where I will give you a rectangle, and we might do other shapes too, but we'll keep it simple for right now with a rectangle. And I would tell you some information. I would tell you, for example, that my rectangle is 8 by 17. I have a rectangle 8 feet wide, 17 feet long, and then I will give you some additional information such as that I will decrease the measurements by a certain amount. What's that amount? X. So when it comes over here, when it comes time for us to think, well, what is X? We can say, oh, X is the measurement by which each side decreases. Okay, great. Now, don't work too quickly, because some of you might be tempted to say, oh yeah, X is the amount that it decreases. Well, what's the it? Or X is the amount that they decrease. What's the they? Please be precise. It'll help you follow your own work. Okay, great. Now, let's say I also told you that the area decreases by 66 square feet. Okay, what do we do with that? What do we do with that information? That's how we create our equation. Just like we've done before, I want to say area new versus area old. Well, which is bigger? My new area or my old area? Well, if the area decreases, that means the old area was bigger. By how much? 66 square feet. So I could say if I put those 66 square feet back, now I'm going to have an equation. Okay, some of you are not going to like to think about it that way, and that's okay. Some of you would prefer to say area old minus area new equals 66. That's fine. Whatever the area was when we started, take away the new area, and there's still 66 left. Some of you still might not like that. You may prefer to say area old minus 66. Hooray, bell. And create an equation like that. Okay? Either way, you can check yourself, add 66 to both sides if you want, and you'll see that you have the same thing. Okay? Whatever way you want to write it is up to you, but you must have an equation. It is critical to first set up our equation and then start putting stuff in. Well, what can we put in? Area new. Well, that's also going to be a rectangle, but what are the dimensions of my new area? Instead of 17, I took away x, so now I have 17 minus x. Similarly, for the width, I had 8, I took away x, Now my dimension is 8 minus x. So what's my new area? Remember, area is length times width. So my new area is 17 minus x times 8 minus x. Okay, again, I have a rectangle. The length was 17. Chop off x. What do you have left? 17 minus x. We've done many problems like that. If x were 3, what's left? 14. If x is 8, what's left? 17 minus 8 is 9. Okay? Same idea. Nothing new here. Nothing that we've done here is new. So that should be okay. We'll see where the new stuff comes in a moment. Now, what's my old rectangle? 17 times 8. Just a regular 17 times 8 rectangle. We can do our work off to the side. Great. I'm just going to write in 136. Okay, now here, let's start multiplying. 17 times 8, well, fortunately we already have that. 136 minus 17x, and then minus 8x, and negative x times negative x is a positive x squared. Okay, now subtract 136 from both sides. Excellent, we already have a 0. That's one thing that we're always looking for, and we already got x squared minus 25x plus 66. Okay, again, nothing new so far. This is all the stuff that we've been doing over the past couple of weeks. Subtracting something from both sides, combining like terms, coming down to a quadratic that we're going to try to solve. The 66 tells us, we know, product of 66, sum of negative 25. You can see, because the sum is negative, we're going to be dealing with some negative numbers here. So that means to get a positive 66, I'm just going to list the negative factor pairs. And here it is. X minus 3 and x minus 22 equals 0. Again, just like we've been doing. And I get two possibilities. Just like we saw yesterday with some number problems, there were some answers that we had to throw out. If the problem specified that the integers had to be positive and we got a negative one, we had to throw it out. Are both of these possible? Let's check our work. If x is 3, what happens over here? 17 minus 3 is 14. And x minus 3 equals 5. What's our new rectangle? 70. What was the old rectangle? 136. Is 70 plus 66 equal to 136? Yes, it is. Fantastic. Now let's try 22. 17 minus 22 equals negative 5. Uh-oh. Can't have a negative measurement. A length can't be negative 5 feet. So that's not a possibility. You must cross it out. You must think about the problem, and if a problem is physically impossible, you cannot say, well, it's this or this. No, it's not this. X can't be 22 because then the problem no longer makes sense. Okay? once we're doing word problems like this, it is essential to stop and think about what's going on. What is it that you're trying to solve for? What makes sense? What doesn't make sense? Okay? Essential. I will go grab another problem. Think about that for a moment. Okay. Now, let's try another problem. This time you have a rectangle, and you are told that the perimeter is 52 and the area is 160. 52 feet, area 160 square feet. That's it. That's all the information that you're given. What would be the dimensions of the rectangle that has these two properties? Okay, so let's start out. X. What is X? Let's call X the width. And what about Y? What about the length? Some of you might be thinking to use two variables, and that's fine. Let's do that first this way. I'm going to do this in the blue with two variables. What does that mean? X and Y are the dimensions, and the perimeter is 52. So that tells us 2x plus 2y equals 52. We can make things a little bit simpler. Divide everything by 2, and we get x plus y equals 26. Okay, so far so good. What about the area? What do I do with these x and y terms to get 160? Multiply. Right? Area of a rectangle is length times width. So the area is x times y equals 160. Here's two variables, two unknowns. If you want to do it this way, you're going to have to somehow combine them. We've done this a couple of times, and that involves substitution. If we get y by itself, and we get 26 minus x, and I substitute it in for here, instead of x times y, I have x times 26 minus x. Right? If y equals 26 minus x, I can just swap them out. Just like we said, if you have a dozen eggs, if I told you a dozen eggs costs $3, how are you going to solve it? Well, you're going to use your knowledge that a dozen is 12. If you don't know that a dozen is 12, you're not going to be able to solve it. So we're substituting dozen equals 12. So now if I know that 12 eggs equals $3, now I'm in business. No problem. Okay. Coming back over here, we've substituted 26 minus x instead of y. And now I can try to solve it. Distribute 26x minus x squared equals 160. That should look familiar. Hopefully you're thinking that you want a positive x squared. So, and I'm going to throw this 26 to the other side, and I'll get x squared minus 26x plus 160. And that should look very familiar and very solvable for all of you. Now, for those of you that don't want to use two variables, that is fine. But then what are your options? Still start out with x as the width. But now what? What are you going to do for the length? Now, some of you might be thinking through this already, and you'll realize that whatever we're about to do is, of course, related to this. But you might say, okay, I know that width times length is 160. So if this is x, the length is going to be 160 over x. That's one option. For those of you that don't want to have to deal with this fraction, that's fine. Still one more option of how to set this up. X equals the width. So what's the length? That's using perimeter. If I have my rectangle and this is x and this is x, and I have two things over here, 2x plus 2 question mark equals 52, what has to go here? Just like I divided by 2 over there. I can now replace, instead of this dimension of length, 26 minus x. The idea is the same. This 26 minus x, it's in both places. It's all a question of how you want to think about it. The option is up to you. 3 options, blue, black, and red. Blue is just using 2 variables, and then at some point eliminating one of them. The black uses our area knowledge. The red uses perimeter knowledge. So then, okay, the red becomes the same as the blue, because if we have length times width equals 160, I have x times 26 minus x equals 160, which is exactly the same as the blue, and you continue there. For those that like the black option, let's talk about that for a moment. Those of you who said, well, if the x is 4, if the width is 4 times what gives me 160? 4 times 40. Great. If x is 5 times what gives me 160? Divide both sides by 5. That's where that division piece comes in. And I know some of you are not liking this option, and that's fine. Focus on the blue or the red. For those of you that like this option, if the width is x and the length is 160 over x, where am I going to get my equation to solve that I'll be able to figure this out? Perimeter. 2 times x plus 2 times 160 over x equals 52. Now again, we can divide everything by 2 to make things a little bit easier. Now this is something that we haven't seen before. We haven't seen a variable in the denominator. What do you think we could do am I allowed to multiply everything by the same thing, multiply both sides? Sure. Will it help? We'll see in a moment. But some of you might be thinking, but wait, we couldn't divide everything, right? We tried once to divide both sides of an equation by x, and that didn't work. Why is this okay? It's because it's multiplying. You're allowed to multiply something by 0, but you can't divide it by 0. So what happens if I multiply through? X times x is x squared. What's x times 160 over x? The x's disappear. X over x is 1. And I'm left with x squared plus 160 equals 26x, which is going to turn into this. Subtract 26x. Plus 160. Okay. And then that's over here. We can solve that. Product of 160, sum of 26. You'll get 10 and 16. And again, you all know how to do that last step. And, oh, actually, one thing I will add, because we do have to check our answers with any geometry type problem. X equals 10, or x minus 16 equals 0. I got two possibilities. X equals 10 and x equals 16. Are they both possible? Well, let's try it out. If x is 10, 10 times what is going to give me 160? 16. Great. What if x is 16? 16 times what gives me 160? 10. Okay? 10 times 16, 16 times 10, same thing. So in this case, both of our answers are in fact possible. In the last one, they weren't. Got to check out your answers. Okay, so again, how did we solve this problem? Step number 1, diagram. Step number 2, write down our information. It tells us perimeter was 52 and area was 160. Step number 3, assign my variables. Whether you're going to assign them as option A, option B, or option C, you have to define them. You have to say, what don't I know that I need to solve for? In the blue, we used 2 variables. In the black, we used 1 variable with x and 160 over x. In the red, we also used 1 variable, but it was very similar to the blue, just with 1 variable and a little logic instead of 2 variables. Now, finally, number 4, step 4, create your equation. This is 4A, 4B, and 4C. Whichever option you're doing, you got to pick one. And then finally, step 5 is the solution. 5 is factoring. Okay? So I will make space over here and write out those steps. 1, diagram. Step 2 is write out the info given. In this case, it was perimeter and area. Step 3 is define x. Step 4, create your equations. And step 5 is solve by factor. And really, step 6 is check your answers. Make sure they're correct and make sure they are valid. Okay? I know there's a lot there. I know that you can do it. The video will be up if you want to look at it again. But for those of you that feel ready to try some rectangle problems on your own, please do so. Have a great day.